Hello everyone. In this kind of tutorial, I'd like to show you my Python generator called shortest path. The shortest path is kind of an algorithm that searches the shortest path of 2 points on a polygon surface. It's well known in Houdini. There is already a node called shortest path, and lately there is also a plugin for Blender called AnyTree that does the same. I think it's built in geometry nodes. So I thought maybe we can do something similar in Cinema. I also tried it first with nodes. It kind of works, but the performance was really bad. So I thought I build one with Python, with a Python generator. And now I like to present this to you, how it works. And you can download it in the description, so you can test it at your own. Okay, let's start. Here we'll see the Python generator with its settings. If you like, you can go here to Object and watch the code if you're interested in. But I will focus now here on the basic settings. So first, let's build a surface. Let's take a plane. Let's show the wireframe. And now best is when you use a poly reducer to make interesting mesh. So here we go to the poly reduction, feed it here. And now you see you get this kind of triangles, but we need some more. So let's make some more segments, maybe 50 by 50. And then you can convert it to polygons. Let's make some point selections. Store them. Call this one start. And let's make another one. Call this one end. Okay, now we have our selections. Let's go to the shortest path object and feed in the polygon object, and then the start here in the point selection start and the end in the point selection end. So let's hide it, and now you can see it generates splines. So let me explain. Make here an X-ray so we can see it, and feed this in a sweep so we can see it. Okay, let's make it maybe red. So, all right. So it starts here from the start points and searches the shortest path to the endpoints. At the moment, just one endpoint is activated, so that means it uses just 1 point of the endpoint selection. That's because it's much faster if it has to search just one. And you can deactivate it, and then it uses all the endpoints. Here we have the maximum iterations. Let me explain this. I will show the wireframe again. And now let's take this to 1. And let's zoom in. You can see here it starts, and then it makes one iteration of searches over its neighbor points and searches which one is the closest to the endpoint. So it decides, okay, let's go this direction. And then you can up this value, and you see we need 8 iterations. So now we have the full paths. For bigger meshes, of course, you can raise this. But more iterations means it's slower. And of course, now you can update the point selections. Let me do this. Maybe make a circle. update them, and maybe the center. Oops, maybe points here in the center as endpoints. And you see it don't update in the viewport. That's a problem of the Python generator. You can switch your setting, or the easiest way is just to go frame forward. I do this with G and F, G forward and back, and it updates. So another trick is you just make here one frame, let's play it, and now you can adjust, and they have always an update. So let's take those, tack, and update. So yeah, that's a little trick for a live update. Okay, that's it for the introductions. And now, as next, let me show you how to build kind of a tree structure. Okay, for a tree structure, we need more like a volume filled with a mesh, not a surface. And I'll show you how to achieve this. Let's make first a torus, a bit bigger, something like this. Set this to X-ray, and next let's make a cloner with a plane. Set the cloner to linear and set it to endpoint. Now we want to fill the volume of the torus with those planes. So let's go to the bottom first, something like this, and then here to the top. Let's make some more planes, maybe 15, and also some more segments, maybe 20 by 20. So now there are a lot of points inside of the torus. First, we want to kill all the points outside of the torus. So we feed in the cloner into a connect object to make it one polygon object. Next, we need a delete node. Go here to the asset browser and search for delete. Feed this inside the connect, and you see it deletes all the geometry. Switch it to points, and now we have to decide which point to delete. Let's make a point selection on the connect object. And it automatically switches to field. That's good. Let's feed in the torus, set it to volume, and then inside delete, we feed in the selection. Now you see it deletes the points inside of the torus. That's the now we want it other way around, so we can do this in here with an invert, or an easier way is to say here write all minus the point selection, and it switches. Now we have all those polygons inside of the torus, and it's all procedural. Next we have to connect all the polygons, because here you see the planes from bottom to top are not connected. So put the connect into another connect, and then raise the tolerance. We hide the torus first, and when you raise the tolerance, you see they start to connect from top to bottom. I think we have not enough polygons, so let's go first to the plane, maybe make them 30 by 30. And here maybe count like 20. Okay, now you see it generates this kind of triangle structure. That's good. So go back to the second connect, maybe lower it there. I think that looks okay. Yeah, that's okay. So now we want to generate our point selections, but of course we can convert the connect to a single mesh here, but we want kind of procedural workflow. So we can feed in a correction deformer, put this here, and now you can see we can collect points straight here on the correction deformer. Okay, let's make first some points here, store them, call them again start, and then some around here, call them end. Let's grab our shortest path generator here, and then we have to feed in the polygon object. For this setup, it's actually the correction deformer, and then again the start points and the end points. So let's hide the mesh, and you can see it builds this structure. It looks a bit too regular, so what you can do is to grab a random effector, put it under the connect object, set the deformation to points, and let me show it, and then lower the strength, something like this, hide it. Again, frame forward, frame back to have an update. Now you see it looks much more organic. Okay, then feed our shortest path into a sweep. Okay, and go to detail and scale, oops, the other side, scale here the start, because these are start points. Something like this. At the moment, it looks a bit too edgy. You can counteract this with a smoothing deformer. So that's way too much. Maybe make just 2 iterations. Lower the stiffness. Yeah, and of course you can play with the strength here. Let's see how it gives more smoother edges. Here we have a problem. That's because some of the start points are not reaching the endpoint. So as I explained in the first tutorial, you have to raise those maximum iterations. Maybe let's like 20. Yeah, now you see they grow to the end. Yeah. To let the tree grow, we can use a mouse spline. Put the mouse spline under the sweep and then switch the mouse spline to spline. Go here to spline settings, and you can't feed in the shortest path directly. You have to first put it under a spline mask. I don't know why, but it works like maybe kind of a bug. Maybe in future versions of Cinema this will work. And then feed in the source spline here as spline mask. Hide, so hide the mouse spline so we can see it. And the mouse spline here, the width, decides the width of the tree. Go back to objects, switch to separate segments, and now here with the start can let the tree grow. You can see here are some problems that it's a bug in a Python function that Maxim provides, so I can't do nothing about this, but maybe in future versions this bug will be removed. Okay, let's go to the last step. In the last step I will show you a complete procedural setup with Mo selections. Here in the last example we control the start and end point with fields and MoGraph matrix. So we can adjust start and end points with those fields. So we have kind of a live view. And another difference is the building of the torus mesh. Here I built node setup that generates this volume mesh automatically. So you will find this also in the download file. I don't want to explain this, but here you can feed in the polygon object and of course the count of the planes and then the segments of the plane. So you can adjust the torus and it updates automatically, but it's the same like we did with the cloner. Okay, let me explain how it works with a matrix object. Let's delete it. Let's make it from scratch. First, make a matrix object, then set it to object, feed in the correction deformer, and then set the distribution to vertex. And now you see we have on every point we have a matrix. Make them a bit smaller, like this. Then we need two MoGraph selections. So go to MoGraph selections. One duplicate it. This one will be our start. And this one the end. And now we want to control them with fields. So go here and activate the fields on both of them. First go to the start point, the field, delete the freeze, and we use a spherical field for that. Okay, place it here. Then go to the end. Also delete the freeze. The spherical field, place it here. Make it a bit smaller. Okay, and now we like to have colors to have a preview. Go to the matrix object, make a plane effector, deactivate position, color mode, field color, that's okay. Then go to fields and place both MoGraph selections in here. Then go to remapping, enable remapping, color remapping, and switch here to color. And now you can choose a color. Maybe let's make red here for the start points, for the end the same. Make them blue. Okay. And we have here a fall off. Of course, can go to the spherical fields, to remapping and delete the fall off. Okay, then go here to the shortest path generator. You see the correction form is already in there. So let's take the MoGraph start selection, put it in here, MoGraph selection start, and the MoGraph end selection, put it in here. And now you see it generates the tree. And now you can play around with them to have a live preview. Just press play. Okay, and yeah, have fun. Okay, that's it. I hope you liked it. You will find the files to download in the video description. If you have some questions or you noticed a bug or something, let me know in the comments. Yeah, bye bye.